All right. Well, welcome, and thanks for sticking around for probably the most important discussion of this entire conference, at least in my opinion. My name is Kyle Clark, and I'm the founder and CEO of Beta Technologies. As I was listening through the conversations this morning, we've heard a few different references to how aviation is going green, how transportation is going to go green, and I actually was really motivated by what I heard, but I was also a little bit confused and disappointed. There was a comment about 2050, 2035 before we see any movement, a 25-year development cycle on a new airplane, and I was just sitting in the back of the room thinking, yeah, that's what it's going to be with that attitude. But there's a way to do it faster. And I'm just going to give you a little trajectory that we've subscribed to get green energy and or electric aviation at a meaningful scale into the world. The aircraft you see on the screen is the ALIA 250 aircraft. But rewinding way back about 22 years ago, Beta started as my senior thesis project at Harvard. And it actually won the Thesis of the Year in 2004, but I couldn't get anybody to invest in the business. So I started pursuing other endeavors in electrification, grew the businesses, sold them, grew the businesses, sold them. And finally in 2017, I met Martine Rothblatt, who said, I believe in what you're doing, let's go do this, but I want to offer a quarter-turn adjustment. And her insight was quite profound. She said, you're focused on the wrong market. You want to move people? Let's move the most critical cargo, organs and tissues, pharmaceuticals, transplant organs. And then she said, but right now it's a technical issue. People don't believe electric aviation is real. So we went out, and instead of telling people it's real and convincing them of the numbers, we designed, built, and flew a 4,000-pound electric aircraft. It was the largest aircraft in the world. Then the next thing came up and says, electric aviation doesn't go far enough. There's range anxiety. There's batteries are heavy. We kept hearing that. And we said, okay, well, we could try to convince people, or we can go and design and build and fly an aircraft. So we went out and designed, built, and flew an aircraft, and we were over the moon when we hit 100 miles. Then we hit 250 miles. Which at the time we started the program was a theoretical intersection of empty weight fraction, slipperiness, lift-over drag ratio, propulsive efficiency, and the dreaded battery energy density. When you did the math on the four of those, we were hitting 250 miles. Well, we hit that, and we realized in the 2 years it took us to get there, batteries had gotten a lot better. So then we said, well, what can we actually get? And we went out and we set another world record and flew 336 nautical miles with that airplane on batteries alone. Now, 336 nautical miles is just under 400 statute miles. Now, back to Martine's insight. The idea that we had to start with the right mission, not moving people, we wanted to move cargo. We went to UPS and said, hey, what's your mission? Well, they've got all these regional feeder fleets. The average range of one of those feeder fleets is 115 nautical miles. So now we have commercial closure, we've got the technical solution, and we ran headlong into what I'm going to tell you is the biggest issue in introducing clean aviation. It's regulatory and it's economic. It's not technological. So now we face the regulatory environment, and the question we ask, what is the clearest path to regulatory acceptance of an electric airplane? And I'm going to rewind for 1 second. We hear about aviation. If we don't do anything about aviation, by the way, it will be the #1 producer of carbon emissions in transportation by 2035. That's just around the corner. Why is that? Because we got micromobility that's already gone electric. We've got cars that are going electric. Locomotives went hybrid electric long ago. They're very efficient. We got marine that's gone electric over short haul, and aviation's operating this cognitive dissonance saying, no, we can't do that. Turns out we can. And if we don't do anything about it, then it will indeed. We saw that first slide, which as I was walking out, said that aviation will grow 3 times by 2050. We have to do something about this. Now, where's the right place to start? So we believe that the right place to start is actually in cargo and logistics. And by the way, this is a great metric here. All of Germany versus aviation, for example. Germany is a big country. So let's start with short-haul stuff, because we can do a meaningful chunk. That's a Cessna Caravan. By the way, everything I show you here is real photographs. We actually just flew the airplane from Florida back to Vermont. Vermont's way up above New York there. Last week, flew through the Hudson Corridor. Unfortunately, the video's not going to play today, but it's a spectacular video of me circling around the Statue of Liberty and shooting up the Hudson. In the National Airspace System, in Class Bravo airspace, at the convenience of the air traffic controller. This isn't a technological issue. We have to go to the FAA, convince them we have a safe and reliable entry to market. We hear this term air taxis, eVTOLs, synonymously. That's not the right place to start. We have to start with cargo and logistics. And this is of our 600-unit backlog right now, a quarter of them are going to UPS. Amazon is our second biggest investor. The theme is coming together. Now we've got the regulatory path of going into cargo first, which is a lower bar than urban air mobility carrying passengers. The financing is coming together. And the reason I put this slide up here is to tell you that every one of the legs that we flew, by the way, the test team's in that plane, and myself or another test pilot is in that plane. We would charge the thing up, fly 200 odd miles, and it would cost us $14 to recharge the electric airplane and $700 to refuel the Caravan. There is no green premium, and it's fascinating as to why. It's because aviation is dominated with operational costs. The actual cost of the airplane over the life of a 40,000 hour, in many cases, airframe is really not a big deal. The recurring operational costs of engines and fuel is what dominates aviation. You take the fuel out and you charge with electricity, it becomes irrelevant. And if you go to electric motors, which don't put out caustic gases at high temperatures, and they last the life of the airframe, the economics plummet. And as the CEO of UPS said to me, she said, you know what, when we get this thing in service, we're going to sweat the asset. And what she meant is figure out how many times she can fly the airplane versus how few things they can fly, which is their MO right now. So I'm here to tell you that aviation is going electric through a path that many of you probably didn't realize is happening right now, through a company, a private company. We're not a public company yet. We're lucky enough to raise, trusted me, a humdrum engineer and a test pilot with over $1 billion of capital to go do this. And then we went and built a factory in Vermont. So, by the way, the largest net zero building east of the Mississippi, all geothermal and all solar. So we're building them in a sustainable factory. We're running them with electricity. And when those batteries are done operating in the sky, they go on the grid and they provide buffering and arbitrage for renewables. It's a full cycle thing. It's here, it's real, it's happening. And the question was asked to me before coming up here is, can we get to zero in aviation? The short answer is not right away, but there's a huge chunk of commercial operations that we can address today. These are real numbers on the electric grid as it sits today without any trickery around saying that the electrons came from renewables. This is national averages in the US. 83% reduction relative to a helicopter, and in our fixed-wing aircraft, a 75% reduction. That's a meaningful chunk. This is really cool, and it just shows the maturity of this. We had to get special airworthiness permission to fly over the mall in Washington, D.C., out of Andrews Air Force Base. We are well beyond does it work. We are now convincing some of the most staunch regulators in the world that we're safe to fly over the White House. The other thing we've done is we've designed and built a charging network that goes, this is a video that's not going to play, charging network that goes from Burlington, Vermont to Bentonville, Arkansas, down to Texas. We installed our first chargers down in Florida last year. We've been using them, and all the way back up the East Coast. About 100 sites in play right now with a bunch of chargers online, allowing us to fly the entire East Coast of the United States with chargers. So, yes, the answer is aviation can go green. We're quietly doing it up in Vermont. We're looking to expand this not just to cargo and logistics, but then to military, and then to passenger, and then capturing the vertical domain, nip on the heels of the regional carriers, then the transcontinental, and within my career, which I got another 40 years left in, we're going to be flying across the Atlantic all battery electric. So thank you for your time, and I appreciate it, and hopefully everybody got a tiny bit of insight out of that. Thank you.
Thank you so much, Kyle. And there we have Jet Zero. Aviation ambition without a doubt. So there's so much going on in this space. And again, it's actually happening, which is so, so exciting. We're now going to move to sea gliders. How about that? So if you aren't comfortable up in one plane, we've got another form of transportation for you. The co-founder and CEO of REGENT joins us now. Billy Thalheimer is with us.
Hello, FII Miami. I'm Billy Thalheimer, co-founder and CEO at REGENT, where we build sea gliders. Have some amazing stuff to show you, so let's start this thing off. We started Regent because we were trying to solve a problem in regional mobility, where you're at the airport longer than you're on the airplane, or you're stuck in traffic no matter when you leave. So we said, we're going to focus on one part of that. We're going to focus on the seaports, on the coastal transportation. I think everyone has a route in their head that goes along a coastline, which is just annoying to travel today or too expensive to travel today. And when you look at places like Miami or even all around the world, you'll see that maritime transportation hasn't changed much in the past century. We're still using these horrible hydrocarbon fuel-burning ferries. We're moving slow. We're polluting. It's expensive. It's not comfortable. There has to be a better way, and that's really where Regent is focused today. Our founding team came from that electric aviation space that Kyle and Beta and many other companies are working in today. We said, how can we use that brand new technology in electric propulsion and bring it to the maritime domain, where we're taking advantage of ground effect, these aerodynamic efficiencies to give us longer range, like birds flying over the water, and we're going to give our designs wave tolerance by using the latest in maritime technology. We'll use hydrofoils to give us wave tolerance, coupling them together to make this amazing electric, affordable, high-speed regional coastal mobility machine. So Regent started about 3 years ago with this concept. We're going to build a sea glider, a hydrofoiling, all-electric machine, a hybrid of boats and planes that is going to skim low over the water on this cushion of air for very efficient, very affordable transportation. So we started to build one. We wanted to prove that we could operate in all of our modes, that we could hydrofoil in this wave-tolerant condition and then fly at high speeds so we can move around at 180 miles an hour, about 300 kilometers an hour. And so what you're seeing here is also real footage, no CGI in this. We have proven this technology with our prototype vehicle. You can imagine going through the harbors on those hydrofoils, taking off, and then flying on that cushion of air at airplane speeds onto your destination. Importantly, this craft is incredibly easy to control. It's regulated by the Coast Guard and international maritime regulators. You only need a boat captain's license to operate it, and that's because the only controls you have are boat controls, left and right, fast and slow. You don't fly a sea glider. You don't have thousands of hours of training necessary to operate a sea glider. You drive a sea glider. So the next step for us was to say, if this is going to operate all around the world in all conditions, we need to show that it can operate in any weather conditions. And so over the past year, we've put this thing through all sorts of paces, all sorts of weather, and shown high wave tolerance. Now, in our third year, Regent is moving on to our full-scale prototype. So our first sea glider product is called the Viceroy. That is a 12-passenger vehicle. So we're talking about high throughput from day one, incredibly affordable costs. And this is the prototype that the Regent team is building right now. You can see the scale that we're talking about here, the comfort of walking on board and having headroom and giant windows the size of cars. And there's an immense amount of technical work, obviously, that goes on behind this. We're taking the best of aerodynamics engineers that come from space companies, that come from the Boeings and Airbuses of the world, and combining those with the best in maritime technology, the America's Cup, Sail GP, sort of the F1 of the maritime world. So we're working on all the enabling technologies, and not just based on the vehicle. We're building a vehicle that operates at very high speeds in the water environment. So we're also working on the sensor systems to ensure safety, because safety is a critical part of this process, flying at these high speeds and low altitudes. We're going to make sure that our captains, that sea glider captains, even though they're just operating left, right, fast, and slow, are going to have high situational awareness, be able to see everything on the water. So it's been really exciting for me watching over the past 3 years this growing, because now we're actually building the thing. We're using the latest in these maritime composites technologies, and we're actually building this hull. It's about 55 feet long, or almost 20 meters long. We're based in Rhode Island, so not too far away from Vermont up there. We have our electric aviation revolution up in New England, and we're putting these composites together. We're using boat builders to build a flying machine, because it is truly a boat that is meant to fly rather than an airplane adapted to the water. Now, Regent's first vehicle, you're looking here at this Viceroy vehicle. Again, it's a multi-mission machine, so we're starting with commercial transportation that can start in sort of your economy configuration, and we certainly have customers interested in that, investors like Japan Airlines and Hawaiian Airlines. But we're also looking at VIP configurations. We're looking at cargo configurations. We're looking at maritime patrol, medevac, and even military configurations for this craft. Incredibly capable platform. The great thing about all of this technology, about the ground effect, that cushion of air, and the hydrofoils, is that it actually gets easier with size. And so once we develop that 12-passenger Viceroy sea glider, we move on to our 100-passenger Monarch sea glider. And this halves the costs again. So a 100-mile mission today, about 160 kilometers, you're going to talk about $40 in operating costs on the 12-passenger. We'll move into about $20 on that 100-seater. Where are we going to operate these things? Well, it's pretty amazing here in Miami. We have this amazing history. Actually, this is Town Hall in Miami, where we used to have flying boats, the Catalinas, operating all the time. And so that market still exists. People still move around coastlines here throughout Florida. And so we're going to bring that back, and we're already in conversations with the city and the county level to identify places at Port Miami and then grow our operations, interfacing with multimodal transportation here over time. And the best part is we can use areas of the dock that are very shallow, that aren't meant for the big boats because we have a very low draft. And in many cases, the electric infrastructure is already there for the ferries and the cruise ships. Regent also has a lot of traction in the Middle East, and very excited to be here at this FII. We were at the one in Riyadh as well. There are 5 million passengers today alone that are moving along these coastlines on the Red Sea and in the Gulf. We were very excited this year to announce NEOM's participation, investing in our Series A, and you can tell just from where NEOM is based the importance of the water transportation to them. So we're imagining a Red Sea connector on that side, and on the Gulf side, additionally, we see millions of people moving, and that is only growing every year. So you can imagine the air transportation that this offsets, but not just from commercial passengers. We're in conversation with police for maritime patrol and police missions, for offshore energy, oil and gas, and offshore wind. So we are doing all multiple mission development. We're making this real too. In addition to the technology, we're working on our manufacturing facilities, opening these very soon so that we can deliver these sea gliders by mid-decade to our customers around the world. So incredibly exciting year for Regent as we work to put human beings on a sea glider, fly them by the end of the year for the first time ever. We're incredibly excited about the future of sustainable coastal transportation. Again, I'm Billy Thalheimer with Regent. Thank you.